So let's start the webinar. A very warm welcome to all of you. Thank you to each one of you for taking your time out and joining us today. My name is Priya Chakravarti and I'll be your host for this session. Welcome to the webinar on on-demand multi-tenancy reference architecture for NVIDIA cloud partners and AI cloud providers. Before we jump to the webinar, let me introduce to our speaker today, Sriram Rupanagunta. He is a co-founder and CTO at Arna Networks Inc. and heads the engineering team. Prior to Arna, Sriram was the head of India Engineering and Data Center Business of Western Digital Corporation. Prior to Western Digital, Sriram was with SSD-based startup Viridian System, which was acquired by Western Digital. Earlier to that, Sriram was also the co-founder of a startup, Arohi Communication, which was acquired by Emulex Corporation and was a vice president of technology at Emulex. Hi, welcome Sriram. Our next speaker is Milind. Milind, who has over 2 decades of expertise in the telecom domain and has been engaged with many tier 1 and 2 telecom operators in helping them define their solution stacks and delivering the project requiring a mix of telecom and technology expertise. Currently in Arna, he's playing the role of principal consultant and mostly involved in the technical side of go-to-market. Please feel free to post your questions anytime on the chat window and we will answer them at the end of the presentation and demo. So let's dive in today's session. So I welcome Sriram and Milind and I'll hand over to Sriram to take it further. Over to you, Sriram.
Okay, thank you. Thank you, Priya. Hello, everyone. So today we'll go through the webinar with the topic on-demand multi-tenancy reference architecture. And this is for the NVIDIA cloud partners, also called NCPs, or any general AI cloud providers. Yeah, if you can move the slide. So the agenda for today is, so first we'll talk about the motivation for the on-demand multi-tenancy, and then the typical deployment architecture, which is required for supporting this. And then various user personas and their roles. And then we'll talk about Arna.ml CMS, Reference Architecture Blueprint. So the CMS stands for the cloud management software of Arna.ml. And then the various consumption models, their bare metal, virtual machines, or a platform, the platform features as service. So all of them will cover. And lastly, the potential use cases, then followed by a demo. So Milind will take care of the demo. So firstly, the motivation for the on-demand multi-tenancy. So why do people even care for it, right? So our current use cases where people use statically allocated resources. And they use manual workflows to provision, monitor, build, and scale. So this has been there for quite some time. Now, the problem with that is that, as you see on the right-hand side, the points there, the GPUs get refreshed frequently, right? So with every generation of GPUs, so there are going to be the ROI challenges for the NCPs, especially with the older generation GPUs, right? So. And the static clusters that I just talked about typically serve the long-term LLM trainings, right? So when people allocate them for duration of several months, and then so there's really no need for doing any static, any dynamic change of these resources. So that works well for these types of workloads, the long-term LLM training type workloads. And then lastly, the lower ROI is because of the manual operations, because there is going to be a lot of manual intervention required, especially if we need to do any dynamic type workloads, which we will cover in the subsequent presentation. So now, what do the NCPs and the AI cloud providers want? And what is it that we are hearing from them, right? So the first one is that they want to offer the GPU as a service, right? So they need a software layer which takes the physical infrastructure and provides a cloud layer which will enable you to offer it as a service. And using that, essentially, they want to build hyperscaler grade AI clouds, similar to any of the hyperscalers. And they need to be API driven, elastic, and of course, you can do it through the user interface, the GUI interface, and so on. And using that, they want to transition from static GPU rentals to fully dynamic multi-tenant on-demand infrastructure. So which is essentially what we're going to cover in today's webinar, how we enable that. So, and then lastly, the GPU providers, the AI cloud providers, want to offer multiple services on the same GPU infrastructure, right? So they want to offer bare metal services, they want to offer virtual machines, they want to offer a platform, which is higher level functions, job submissions, model serving, inferencing. So they want to offer all of them on the same infrastructure, so not using different islands, right? So that's essentially what we talk about today. And what we see is that there is a huge IRR improvement, close to with this dynamic allocation. And if you're interested in that number, you can contact us. There are some details on our webpage that you can take a look at. Now, what are the business approaches and the challenges? What do businesses can do to solve this problem, right? So the first one talks about the options to implement this reference architecture, the CMS reference architecture. So the first option is do it yourself, right? So obviously, if you have a lot of engineering, the teams, you can do it yourself. Typically very long and expensive cycle, right? So that's one option. The second option is a bag of tools, right? So you can actually pick up a lot of the tools that are available, a lot of the open source tools available, which are typically fragmented, so they're not well knit together. And you can build a solution. You can somehow cobble up a solution together, right? The third option, which is what we'll mostly cover today, is a comprehensive solution, which is a fully integrated, which you can deploy and use it. So that's so these are the options. Now, what are the challenges that with either of these options, right? What are the challenges that you'll encounter? So one is unified multi-tenancy, right? So the multi-tenancy has to work across the various layers, right? CPUs, GPUs, memory, storage, networking, InfiniBand. So we have to do the multi-tenancy at all layers, right? Secondly, the diverse workloads, right? So it's not necessary that all of the tenants, all of the users will be using them for training, for example. So some of them could be using them for training. Some of them could be fine-tuning them. Some of them could be using inferencing, where the requirements for the infrastructure are very different. So that's another challenge. The third one is the optimal GPU utilization, right? So a lot of these problems can be solved by throwing a lot of resources at it, right? So your GPUs may not be fully utilized, and if you're okay with that, that's certainly an option, right? But obviously, you don't want to underutilize. These are expensive resources, and you want to optimally utilize all your GPUs across these different types of workloads. So these are some of the challenges that you will encounter in this domain. Now let's talk about the solution that we're going to cover today, right? Which is our GPU CMS, which is cloud management software. Now the software has two layers, right? That you see at the top. So the bottom layer of the software is called infra manager. So this is the layer that provides the multi-tenancy with full isolation. As I mentioned earlier, it can do the isolation at all layers in a very seamless manner, right? You can do it at CPU, GPU, the networking, which could be Ethernet or InfiniBand, or both, storage, external networking, connectivity to the outside world. So all of them have to be tackled in a completely seamless manner, right? So that's one layer. The upper layer is the PaaS and the self-service. So this is really the user-facing layer, right? So the bottom one, you can think of it as the administrator-facing layer, and the top one is a user-facing layer, where your tenants, once you create all these multiple tenants, they can log in, they can create instances. Could be bare metal, could be virtual machines, could be CaaS clusters, and then they can use the job submission, model serving, and so on. So they can support all of these various features. Now, what you see at the bottom is a GPU grid, which is kind of the vision of NVIDIA as well, which is that the GPU clouds can span all the way from edge to the centralized data center. The edge sites can be, for example, things like RAN sites, right? So where you will have some of the GPUs and you want to use them for different types of workloads, typically the 5G RAN type workloads, and also for machine learning, right? Whereas your centralized data center is, which is what we'll cover, we'll focus today, is your data center where you can create multiple tenants and allow them to use these GPU resources. Now, let's talk about a typical deployment architecture, which is fairly common among most of the GPU providers or NCPs, and some of it is pretty much aligns with the NVIDIA's reference architecture as well for their NCPs. But this can be independent of that. So now let's cover the various components of that, right? So if you look at the bottom, which is the GPU compute nodes, so these are your servers, right? If it's NVIDIA, it could be DGX, AGX, or even MGX type servers, which are the resources which will need to be carved up for multiple tenants, right? So, and then you have the other critical component, which is the high performance storage, right? Which is the bottom right block that you see, right? So because storage is going to be a very critical piece in your AI clouds, because you need a very high performance storage for all your trainings, for fine-tuning workloads. And there are several vendors which offer these high performance storage specifically for the AI machine learning type workloads. And we'll talk about some of the integrations that we have done as part of our reference architecture. And then on the left-hand side, above the servers is the networking fabric, right? So, and this is the east-west fabric for for doing all the compute-to-compute communication. And this could be either InfiniBand or it could even be Ethernet. So depending on what configuration they decide to use, what topology they decide to use, right? The fourth component is what you see on the right-hand side above the storage, which is the converged network for both in-band management and the storage, and also for the external connectivity, right? So essentially, this is the storage. This is the networking through which you access your high-performance storage, either through parallel file system or block storage or S3 type interface, like an object storage. So all of them will be through this converged network. And then there could be a core network as well, through which the external connectivity is provided. And lastly, at the top left-hand side, what you see is the out-of-band management network. Because typically most of the deployments also have an out-of-band network through which you can configure the servers, the switches, you can do the upgrades, you can provision the servers. So all of that is typically done through out-of-band management network. Some of it can also be done through in-band, but typically it's done through out-of-band. And then lastly, right at the top, what you see are the management compute nodes. So typically you don't want to run all your management software on your GPU compute nodes. So you want to dedicate a set of nodes, compute nodes, for running your management. And this is typically where the CMS software runs, our software runs, right? So, and there could be other tools that run on the management node. For example, NVIDIA has some provisioning tools that does a lot of the underlay configuration called BCM. So the BCM also could be running on these management nodes. Similarly, the other OEMs may have their own provisioning tools. So all of them will be typically running on these management nodes. So these are all different networks that you see for east-west, for north-south, for out-of-band, and so on. So next we'll talk about the different personas and the roles. So the Arna.ml CMS is fully multi-tenanted with multiple personas and RBACs. So the personas are what we show here. So right at the top is the admin persona. So either you call it NCP admin, super admin, GPU as a service provider admin, whatever, right? Essentially, this is the persona that owns the entire data center, the AI cloud, right? So that's the persona responsible for onboarding your hardware, setting up multiple tenants, creating the tenants, setting up quotas for the tenants, creating the billing infrastructure for the tenants. So that's all from the NCP admin role. And then typically the admin creates multiple tenants. And these tenants are typically the enterprises. And these enterprises have their own administrator. So each tenant typically has their own administrator. And this admin is responsible for looking at the billing, creating their own end users, monitoring their usage, and making sure that things are done within their quotas. So that's typically the tenant admin. And lastly, the tenant users, right? So each tenant can have multiple users. And these are really the end users. These are your developers, your data scientists, people who eventually consume all the GPU resources, the AI cloud resources. So the personas have permissions which are typically in that order. The NCP admin has the super admin persona. They can pretty much see all the resources. The tenant admin has visibility into their own resources, which are allocated by their users. And users, of course, have limited view. Whatever jobs that they submit, the source resources that they allocate, they can view them. And there's one other persona which is not mentioned here, which is operator persona, which is similar to the NCP admin persona. So you can imagine it as at the top, but it has less privileges than the NCP admin. So it typically has only read-only view. So that is used by the operations people in these organizations, the GPU or NCP organizations, where they can debug, they can download logs, they can troubleshoot. So that's provided by these operations role. So these are the different personas and roles that are supported. So this is a kind of a busy slide. So I will not go into each individual block, but this is our reference architecture blueprint. So first, let me talk about the sort of the big picture, right? So right at the bottom is the AI cloud infrastructure. So that has all of your physical infrastructure, right? There's the CPU, GPU, compute nodes. As we talked about, the east-west networking fabric, the north-south fabric, the external storage, and then all the IP networking for the other functionality, the firewalls and EDA, the gateways. And then there are the blue components, which are from Arna.ml, which are part of the CMS. And then there are some third-party functionality, right? So, for example, there are interfacing that we have done with Hugging Face, with AML ML ops tools, Slurm, and so on. And then there are some of these that are provided by the vendors such as NVIDIA. For example, the BCM, NVCF, and again, we may not have time to cover all of them today, but these are all the integrations that we have done as part of the CMS, so that when somebody decides to use any of these tools, the integration is already done. So it will be a very seamless operation. And then on the right-hand side, what you see are all the cross-functional features, all the single pane observability and monitoring, the authentication and authorization, the user personas that we just talked about, the billing metrics, and then of course, lastly, the S3P, the stability, scalability, security, performance, functionality that is provided by the CMS. So these are common across all the layers, right? So these are some of the generic functions, and then we will cover some of this functionality as course of the demo. But at a high level, what you see at on the far left is some of those blocks are infra manager. There's another block which is the PaaS layer that I mentioned, and then the top portion is the self-service layer, where you can submit jobs. You can pick models from Hugging Face, for example, and run some inferencing on that. You can do some fine tuning of that. You can associate some storage, your own data with that, and do some fine tuning. So these are all features that are supported at the self-service layer. And then PaaS is where you provide all the clustering and so on. For example, you can create your own Kubernetes clusters in a fully isolated manner, and then use your cloud native functions to deploy on that. So these are the functions. So essentially, each of this layer is fully independent. So you can choose to use only part of the functionality. For example, if you want to use only infra layer that supports all the isolation, you can do that, or you can use along with the PaaS, and then along with that you can also use self-service. So each of them are modular. And then there are the different consumption models that I briefly talked about at the beginning. So the first one is the bare metal as a service, right? So this is where a lot of the existing customers might be using, right? Because they've been doing their training, which typically for which they use the bare metal. So what they can do is using the CMS infrastructure, they can allocate bare metal servers, either one or any number of them, based on their quotas. And when they do that, so you can see in the bottom picture, right? There are multiple tenants, tenant 1, tenant 2, for example. So each one will be given a slice of the functionality in a fully isolated manner. For example, tenant 1 can have their own east-west overlay network. They have their own VRFs. So everything is fully isolated. And they will have these two nodes, for example, node 1 and node 3 in this example. And similarly for tenant 2, there is node 2, node 4, which again are fully isolated, right? So once the user allocates these, or the tenant allocates these bare metal servers, the software, the CMS software, takes care of all the underlying isolation, all the automation that's required to program the switches, the InfiniBand, the storage. So by the time they allocate the servers or servers, they can be assured that everything is in a fully isolated manner. There's a independent VXLAN for their servers, independent InfiniBand. Their storage slice is fully isolated. So all of that is done under the hoods. So that's the first service, which is bare metal as a service. The second model is the VM as a service, which can be used along with bare metal as a service. So again, even though we are talking about them as independent services, they can actually be used together, right? So there is no reason why you should use only bare metal or only VMs, right? You can actually use a combination of them. For example, in this case, we are showing tenants using both virtual machines and bare metal, right? For example, the tenant one in this example uses uh, a virtual machine that has 4 GPUs, right? Typically, the HGX server, for example, has 8 GPUs. So you can decide to create two virtual machines on that server, one with 4 GPUs, another with another 4 GPUs. And these are all, again, fully automated. So you don't have to actually manually do anything. So once you create the tenants and create these flavors, which are created by the administrator, um, the user typically just allocates these VMs, and they could be with any of these flavors. So again, going back to this example, the tenant one can allocate one virtual machine with 4 GPUs, and the tenant two can allocate one VM with 4 GPUs and another bare metal server, which has 8 GPUs, for example, right? So in this case, they are actually using 12 GPUs, right? And and again, all of the isolation principles work exactly the same way, right? So again, these VMs will be fully isolated from each other, from each of the tenants, and we show all the overlays in this example. So I'll not go into all of the details, but essentially the point is that each tenant, their resources are isolated, and if the servers have Bluefield BF3 DPUs, we can make use of their HPN functionality to create all of this overlay networking. If they don't, we can still use the host with a slightly reduced performance. But essentially, both methods are possible. And lastly, the consumption model that we're talking about is the PaaS, right? So, which is the platform as a service, which essentially is a clustering, right? So here there are two ways to do that. The preferred approach for multiple tenants is the first one, which is hard isolation. So in that case, essentially, each tenant's resources are used to create a single cluster, right? Or it can even be multiple clusters, right? If they have multiple organizations within their tenancy, they can create multiple clusters. Or within a single cluster, they can create namespaces. But the point here is that each tenant's cluster is fully isolated from another tenant's cluster. So there is nothing that's shared between them. It's not a single cluster with multiple namespaces. They can be assured that if each tenant is running their own workloads, their workloads run in a completely isolated manner. For example, NCP could be supporting two competitors, right, as their tenants, right? So obviously they don't want to share anything between them, between their resources, right? So in that case, each of the tenants can be using their own independent cluster, and they can create multiple namespaces or a single namespace. It doesn't really matter, and then they can run their workloads on those, right? So that's the hard isolation, which is the preferred approach for the NCPs. There is also another mechanism, which is soft isolation, which we can support for some of the use cases where such a strict isolation is not required. So in that case, we can create a single cluster across all of their workloads, all of their resources, or it could even be a subset of the resources. And then within that cluster, we can create multiple namespaces and use them for different users, right? So both options are possible depending on how the NCP wants to provide these services. And then, so these are some of the advantages of the reference architecture. Again, I will not go into each one of them in detail, but essentially the points that some of the points that I've already made are so one is you can optimize your GPU utilization because now we don't have to allocate certain set of servers for only bare metal and some for only VM and so on. You can actually use them in an optimal way. All your operations are simplified because you no longer have to do a lot of these operations by running some scripting and your own homegrown tools and whatever. It's a comprehensive multi-tenancy framework. So again, we take care of it at all levels. Storage, networking, InfiniBand, all of them are taken care in a seamless manner. The multiple use cases can be addressed. And it's fully aligned with the NVIDIA's reference architecture guidelines. So we follow all of the recommendations from the NVIDIA's reference architecture. And lastly, there is extensibility and integration with third-party tools. So we have done some of the integration with some of the third-party tools that I mentioned earlier. For example, with Hugging Face and NVIDIA NIM and so on. And also with different Kubernetes distributions. And since it's all API driven, or can be API driven, it is extensible. So you can actually integrate with other tools that are of your choice. And these are some of the potential use cases that are enabled by the reference architecture. So again, I'll give a quick overview of that. In the interest of time, I won't go into the detail, but the first one is obviously the large scale LLM training and the inferencing. So that's clearly something that you can do. The AI workloads in virtualized environments, you can do it with using virtual machines. The enterprise AI development on PaaS, the model deployment and AI services for end customers. For example, some of your tenants could be creating these models and deploying them for inferencing for their customers, right? So that can be done. The dynamic GPU allocation for on-demand workloads, which is what we talked about. The multi-tenant infrastructure slicing, which is again a kind of a standard feature where we can slice the infrastructure for multiple customers in a fully isolated manner. So these are the potential use cases that the RA enables. Yeah, so with that, I will turn it over to my colleague, Milind, to walk you through the demo, which will showcase many of these features.
Thanks, Sriram. So, it's a demo time now. So whatever Sriram explained, I think we'll just, in the interest of time, fast forward through all the functionalities that Sriram talked about. Um, so this is in short what we'll cover today. We will cover few functionalities of the infra manager and few functionalities of the PaaS and self-service layer. So as part of infra manager, we will start with the discovery of the topology. Then we'll also show you how we do the bare metal provisioning. We'll show you how when we onboard the tenants, the isolation of the network takes place. We'll also quickly show you few of the observability and self-correction features of this software, CMS software. We'll show you the InfiniBand isolation. We also have integrated with external storage from VAST. So we'll show you how that is also a seamless experience. And then quickly on the PaaS, we'll show you the integration with one of our partners, billing partners, Monetize 360. So in a single pane of glass, you will be able to view your usages and view your invoices for that. For PaaS features, we'll cover the cluster creation and job submission. So this is really a very quick, we'll have to fast forward that in the interest of time, but we have the detailed demos in on our YouTube channel, and please do feel free to look at it at the later stage. So just let you be some time where I'll Yeah. So this is our login screen. Let's log in as an NCP admin. So this is a dashboard. Since we just have logged in and we haven't onboarded any infra, you can see that the counts are zero, but you can see the GPU counts, the servers, the storage, the switches, etc. Let's now discover the infra. We have two ways of managing the infra. One is a totally automated way where we just discover in a totally automated way. In another way, we can also import the infra where, for example, initial deployment is done by some of the professional services organizations. Then we can import that infra if some day zero and day one activities have already been done. But here in this demo, let's just discover the infra. So as part of infra discovery, we just give the number of tiers of that switching, like 2 tier, 3 tier topology, the MAC addresses, and through LLDP based discovery, it's all automated. The software discovers the entire topology. You will see in a while. Yeah, so you can see the leaf spine core switches at the bottom. There are all compute nodes. There is also the management load on the left hand side. That's not shown here, but this is essentially what all you have discovered in a completely automated way. Now we'll validate the topology because generally all of this topology is designed as part of your design activities. And while cabling, if there are some manual errors, it will be very hard to debug it. So what we do is we take a design topology, we input that as a file and we compare it against what has been discovered. So you can see that the topology validation is successful. Mm, and you have a JSON format of all the topology. This is the updated dashboard. You can see the total number of switches has gone up 21, 10, etc. Now let's go and create the underlay network. So the next step, now that we have discovered the whole topology, where in GPU CMS we have an interconnected inventory of the hardware, the switching fabric, everything. Now we need to create an underlay network. So all the IP address assignments for the switches, for the bare metal, that automation also needs to take place. That is, we do that in a completely automated way where all the BGP underlay configurations happen. See now, all the IP addresses that have been assigned to various switches. The whole underlay network details is what you see. So now this infrastructure is ready. You can assume that the day zero activities are now done, and now you can onboard the tenant. Just I wanted to state that though here for simplicity we are all doing that through NCP admin, but we really have a granular RBAC, and all of these roles can be assigned, and typically this would be done by the tenant admin. But now let's go and add a tenant. Let's add another tenant. So we have two tenants which have been added. Let's go and see those details. You can see that the networking part is done. We'll now onboard a bare metal, like whatever the bare metal infrastructure we discovered. Now, few of those needs to be allocated to the tenant. Here we are selecting bare metal for allocation. And this is the catalog. The NCP admin can create this catalog. He has a different interface for that, wherein he can create, or even the tenant admins also can create a catalog based on their requirements. So let's select one of the flavor, give the operating system that we want to install, the CUDA versions, the number of servers, and we'll select some pricing and just say allocate. So behind the scenes, all overlay network is getting configured. But before that, the bare metal is getting provisioned. we have integrated with canonical MAS for bare metal provisioning. You can see all the logs where the node was powered on, the OS was installed, and you can see one of the server, has been successfully provisioned. So the bare metal has been provisioned. The next step is the network overlay, which you will see in shortly here. Yeah, you can see an isolated tenant network. So for this particular tenant, it has a different subnet, it has different IP addressing, and all the bare metals that have been allocated by this tenant for him or herself, will be on this subnet. So they get a completely isolated east-west network. Quickly, let's go on to the telemetry. We have integrated with NVIDIA NetQ. We'll subscribe to few of those events, which is link up, link down, BGP state change types of events. Let's go to the dashboard. So here we have simulated a link down error, and that's what you can see that there is an error which is down. But the interesting part is we do auto correction. So we have a closed control loop, so we monitor it and we do an auto correction. Let's refresh it. Yeah, you can see that the state is resolved for that. Similarly, we also have a different auto correction use case, which is the config diff simulation and auto correction. Here, you assume some scenario where someone just takes out a switch and probably or does some upgrades, and there is a new version of that switch. So R0.ml GPU CMS will automatically find out that there is a configuration difference, and whenever that switch again becomes online, it will take a golden configurations and apply to that. So that you can see at the top that event file has been updated. So yeah, this is one part of that infra manager where you saw bare metal allocations, the network isolations, and some observability and some features which are really cool for the operations guys, automated features. Now I'll take you through the UFM for the InfiniBand isolation. So we are logging here to the NVIDIA Unified Fabric Manager. We have integrated with them. I'll just first show you the topology on the through InfiniBand of the InfiniBand network through UFM GUI. So this is a very similar topology. Now let's discover that topology in a very similar way that we discovered for the Ethernet network some time back. So we are doing the discovery by the UFM, a very similar topology that you see. Now again, let's start adding a tenant. So here the isolation mechanism is different than for the Ethernet. That was a VXLAN based isolation. This is a P key based isolation for InfiniBand network. So essentially what we do is we create a unique P key for every tenant. So we created a tenant and at the backend CMS integrated with the UFM and created the P key. I'll just go and show you on the UFM GUI, just refresh it. And yeah, the second one is what the P key that got created, just by creating a tenant. So now the next step is, let's allocate few bare metals to this tenant. And then all of these bare metals, because of InfiniBand, they again will have to be on that P key. So that we'll see. I'm allocating two servers here. So now all the InfiniBand interfaces of these two servers, because they belong to the same tenant, will have to be mapped to that P key that we just created some time back. So it all happens through GUIDs mapping to the P key. So GUIDs are very much similar to how MAC addresses are there in the Ethernet world. So you can see this particular server has 8 InfiniBand interfaces. And let's go to the UFM GUI. I'll just refresh it. And on the right hand side, you can see all the bunch of, all the two servers, around 16 InfiniBand interfaces are all mapped to this P key. So that's about the InfiniBand isolation. Let's do the external storage allocation. We have integrated with VAST. And again, this is very simple. We just go and allocate a storage, say parallel file system. We select VAST. We select the compute node on which that external storage mount point has to be mounted. We specify the size. Here I specify 1000 GBs and just say allocate. So that's all. At the back end, it is all done. We integrate with VAST, and you can see the mount point also that got created on this particular node. Let's also validate that on the admin GUI of the VAST. Yeah, here you can see the server being Ubuntu 01 name, the mount point is there, the storage what is allocated, and this is the admin GUI for the VAST. You can see the virtual the north-south isolated network pool that is created for this. The tenant view where you can see tenant hyphen Arna being created, and you can also see the mount point. So that's very quick overview on the storage part. Now let's do a billing part. Now billing, as I said, we have integrated with our partner called Monetize 360. We give a single pane of glass view, so you don't have to switch between the screens. So this is an NCP admin screen where you just set the pricing for the on the catalog item. So you are setting here some hourly price and you save it. Once you save it, that also gets created in the backend with Monetize 360 system. And then when the tenant allocates bare metal, he can select the pricing plan, the one that just NCP admin selected. Now we have subscribed for 2 servers. Those are getting provisioned, and quickly we'll just go to the billing link, and you can see that there are 2 invoices generated for those 2 nodes that had allocated, and you can just click and you can see the invoices, the dollar amount. So that's a very quick on the billing functionality. I'll quickly go through the PaaS where we create. Now that you have seen that we do all the infra management, the network fabric, the underlay, overlay, bare metal. We'll quickly see the Kubernetes the PaaS creation. So I select a cluster and I say create. There are few bare metals which have already been discovered by us, provisioned by us. Using a kind cluster, we select the control plane node, and then we select the number of worker nodes and say allocate. There are various other Kubernetes distributions also. For this demo, it was just a kind cluster, and yeah, that's it. You can see that the cluster has been created. Lastly, on the job submission, so here we will be showing you one of the fine tuning jobs. So the process starts with the user selecting the GPU of his interest, selects the GPU, and then he gives the instance name details, and he selects the job submission and gives the details of all the job related parameters, model names, and all other parameters that are related to the job. And we also select object storage, because for all these fine tuning or SLM kinds of requirements, you need an external object storage. We have integrated with Amazon S3 bucket here. So the user can provide an S3 bucket references. So from where the training data could be imported or persisted also. So we give those details, and you're all set. Then you have given, you don't have to create the VM manually, because this is a job submission. It will figure out the VM itself. We are just adding the SSH key so that we can access the VM, and we have added, we just validate all that and just say launch. So here you can see that it is getting provisioned. uh, you can select the jobs, and it is still pending, it is not completed. Let's go to the observability, and on this dashboard you can see some GPU utilization, and you'll shortly see the GPU utilization going up from 6% to somewhere around, I think, 45%. Yeah, that you can see, because that's why, because the job is running. So there is a spike in the GPU usage. So yeah, I think that was what all that I had to cover, because again I had to just fast forward it in the interest of time. But as I said before, There are detailed demos also available on our YouTube channel, and please feel free to go through the topics of your interest. We'll also leave some time for Q&A. So the forum is open for Q&A. I'll request Priya to
Yeah,
uh, yeah, to just
start the
see.
QA. Yeah.
Yeah. Thank you.
So we
Thank you.
got
Thank you
our
very much.
first question. So are you modular? That means can Arna ML CMS offer only the infra layer or the PaaS layer separately?
Yeah, I think we
Yeah.
briefly covered that in the presentation. So the infra and the platform are, fully independent. So if somebody decides to use only the infra layer, they could do that, or they could use it along with the platform. So these are fully modular. That can be used independently.
Thank you. We got our next question also. Which Kubernetes distribution do you support, and are they compatible with NVIDIA GPUs?
Yeah, so the CMS itself doesn't contain a Kubernetes distribution, but we have integrated with different distributions. By default, we can support the upstream Kubernetes. We've also integrated with Red Hat OpenShift, for example. So in fact, there was a question that, is this equivalent or better than OpenShift? So the answer to that is that it is really not a comparison with OpenShift, because the CMS can work with OpenShift, right? So we have integrated with OpenShift. So it's not a apples to apples comparison with OpenShift. For example, if you decide to create a cluster for your tenants, right? So that cluster can be Kubernetes cluster can be OpenShift based. So if I have a license for OpenShift, we can directly invoke OpenShift and create a OpenShift based cluster, right? So and similarly, there's SUSE, Rancher, and so on. So we have done integration with different Kubernetes distributions, and they're all compatible with the NVIDIA reference architecture.
Okay. Okay, here the next question. Great demo. When can we integrate with DD and Inventia and XLR? Great for your clients. I mean,
Yes, absolutely. So
yeah.
we agree. So in fact, we have started the process. So we should be shortly announcing with RDN and with Weka as well. So with both these vendors, we are doing the integration. So we'll be announcing that shortly.
Great. Okay.
Priya, sorry, I see one question.
Yeah.
Can the roles for the personas be integrated to an existing OAuth to IAM like Active Directory? Sriram, would you please answer that?
Yeah, can you repeat that?
Can the roles for the personas be integrated to an existing OAuth to IAM like Active Directory?
Okay. Yeah. So the authentication and authorization is fully integrated with Keycloak. There's a LDAP interface integration as well. So let's say if multiple tenants want to use different identity providers, that can be done as well. For example, some tenants may use Google for identity, as a provider. Some may use Microsoft, or some may use some local. All of them can be supported, and it can be independent. So each tenant can have their own identity provider, and we can support that. And if they have their own roles, they can get mapped to the CMS roles. Their own admin, their own users, so they can all get mapped to this seamlessly.
Yeah.
And there was another question about the hypervisor being used. So we use a KVM hypervisor.
Okay. How do you compare with other competitors? They also seem to support multi-tenancy for AI cloud infrastructure.
Yeah, so there is sort of two categories of these competitors, right? So there are the orchestrators, generic orchestrators, which obviously don't support all this isolation and the infra orchestration and so on. So that's one category. And then there are some other competitors which support different layers, right? Some of them may be supporting networking, some of them may be supporting, doing a Kubernetes-based multi-tenancy. So what we do is really all of them. So we do it at all layers, in a fully isolated sort of hard isolation for tenants, though we can also support soft isolation. So that's really how we kind of stack up against the other solutions.
Okay, so here comes our next question. Is Run AI essential as a part of PaaS functionality? What are the options?
Okay, I'll answer that. Radhya is not very, it's not a mandatory stuff, but as Sriram also touched upon, it all depends on the use cases that the NCPs plan to offer. So, for LLMs and also there is no one size fits all for different. So while Run AI or other job schedulers might be good for one kinds of use cases and types of workloads, it might not be best suited for the other. So we support integration. We co-work with Run AI or any other job schedulers of NCPs or customers' interest. And while we also support a native job scheduler from as part of the PaaS functionality. So yeah, that is kind of a brief answer to that. I don't know if Sriram, if you want to add anything, but yeah.
Yeah, I think that answers it.
Okay.
Yeah.
Okay. How exactly do you achieve GPU optimization?
Um, yeah, so GPU optimization is achieved like we saw in the some part of the demo where essentially there are two aspects to it. One, to from a monitoring perspective, understanding that what is the utilization, and then the action part of it. So because we typically what we do is, if we see that there are a few free GPU resources, we can add those worker nodes to the dynamically to the Kubernetes cluster, so that it can handle the load. So adding that node or removing that node from the cluster, scale in, scale out. So those kinds of things we do, and we also have the closed control loop functionality through which we can optimize the GPU utilization, and then the scheduling part that I just talked about.
Thanks. Thank you so much. I think we need to close the webinar due to the time constraint.
I
Can you
think
see if there is any question?
there's one question. Um, I think how user prepare for zero touch provisioning here? Do user needs to use BCM or MAS? Uh, Okay, so BCM is not mandatory. We do integrate with BCM because we have seen that many of the NCPs, few NCPs do use BCM. In that case, we integrate with BCM for provisioning. MAS is part of our CMS, so it is part of our product. You don't need to externally use MAS, so for bare metal provisioning.
Okay.
And
Yeah.
there is one more question. I think with 1 minute remaining, we can still utilize that.
Sure, sure.
When models are deployed via NVCF, is there a reverse proxy like solution in place for billing customers per token, or is there a alternative route? Yeah, request Sriram to please throw light on this.
Yeah, so this is something that we are actually working with NVIDIA team on the NVCF billing. So we do have some solution where, in fact, once you deploy it through NVCF, you can actually use that for your inferencing. You can make it available to your customers through the reverse proxy. So that is supported. The billing is something that we are working with the NVIDIA team. So we do track the GPU utilization, right? So using that, it can be built. So there is still a little bit of work that needs to be done to make it to fully integrate it with our billing solution.
Okay. Thank you so much, Shriram and Milind. And we need to end the webinar right now due to the time constraint. But thank you everyone for joining, and we really appreciate the effort you all take to join our webinar. See you soon, and please write all your queries at info@arnanetworks.ml and stay tuned. Thank you. Good